So in the previous video, we have discussed about the specialities of a Carnot engine, and we have seen that a Carnot engine is actually an idealization of all possible heat engines, having a maximum efficiency that a heat engine can ever attain. Now the cycle of operations undergone by Carnot's engine is known as the Carnot cycle, or in reverse we can say any heat engine that works through the Carnot cycle can be named as a Carnot's engine as well. So in the diagram you can see the basic design of the Carnot's engine. It's not so proper to say the construction, so I am using the word design here better, because this type of an engine is never constructed, because it's only a prototype, or I can say it's only a design. As per Sadi Carnot's idea, as I told you in the previous lecture, that the working substance here is supposed to be a perfect gas or an ideal gas, one mole of which is taken in a cylinder, and cylinder is fitted with a frictionless piston. We mentioned this frictionless because we have to ensure that the process is completely reversible. All the processes are completely reversible. Hope you remember we have stated two important conditions for a process to be completely reversible. One is that the process should be occurring quasi-statically, and the other condition was that there should not be any type of dissipative forces present in the, or dissipative phenomena that is occurring during the process. So dissipative things are absent. There's no dissipative phenomena are absent. So these are the conditions. So in order to satisfy these two conditions, we propose that the piston is frictionless, means a smooth piston. Smooth frictionless piston. So that is the basic design, smooth frictionless piston. So there is no chance of any heat dissipation due to friction. And the specialty is that whatever thick walls we have drawn, that is adiabatic walls. So these are all adiabatic walls. Adiabatic means non-conducting, right? So all these things are adiabatic. So whatever we have shaded like this thing, so all these are adiabatic walls. Be careful about the design. And you can see the bottom. The bottom of this particular cylinder is considered to be a diathermic. So this is conducting. So that is to be noted. The bottom part is conducting, whereas the sides and the piston as a whole are adiabatic. So if at all heat is flowing out of the system, which is our perfect gas here, or the working substance here, it will be only through the diathermic wall at the bottom of the cylinder. That is the special design that was proposed by Carnot. And as we have seen, there are two reservoirs. So we have defined a Carnot engine to be a heat engine that is working between two constant temperature reservoirs. So this one only we called as a source, right? The high temperature reservoir, which is at a temperature you say TH, and this one is what we called as the sink. So that has been shown here, also, which is at a temperature you say TL or TC in some diagrams. It will be given as TC. And in order to explain the working of the Carnot engine, so he has proposed one more component here, which is a non-conducting stand. So it's an isolated stand. Means if you keep the cylinder over this stand, what will happen? Suppose that you are keeping the cylinder on this stand. You imagine that the cylinder is kept on this stand. So what will happen? The conducting boundary of the cylinder will be now closed due to this top part of the stand. So that the perfect gas system will be completely isolated from the surrounding. So that is the purpose of this non-conducting stand. If you keep the cylinder over this stand, then the bottom part of the cylinder will also become something like the other three sides. It will be also getting isolated. So that once the system or the cylinder is kept on the non-conducting stand, then the system is completely isolated, thermally isolated from the surrounding. Okay, so that is why we are proposing the role of a non-conducting stand. So we will see how this idea of non-conducting stand will be helping to achieve a reversible Carnot cycle in the next session. Okay, so these are the main components of a Carnot engine. So it is having a cylinder fitted with a smooth piston. That is something very important. Okay, smooth or frictionless piston, and ideal gas as the working substance. Ideal gas is used as the working substance, that is shown here, and a non-conducting stand is there, and there are two heat reservoirs which we are naming as respectively the source and the sink. So that is the basic design of a Carnot engine. Now maybe at the bottom of the diagram you can see a picture here. So this particular picture, see this picture is introduced here. I don't know whether at least some of you have seen this particular type of toy. It's actually a novelty toy. It's a toy. Okay, it's a very fancy toy. You might have seen maybe in at your homes, or maybe somewhere somebody has gifted to you. Okay, some crazy fellow who is very fond of scientific toys. Okay, just would have purchased it or shown to you. See, remember, it is a fancy toy, remember, and this fancy toy is commonly known as the drinking bird. The drinking bird. It's a very old design of a toy, drinking bird. There are a large number of toys which will help us to learn physics better, okay, or to understand the basic application of physics better. So this is such a wonderful toy, that is working on the principles of thermodynamics. I can say that all sorts of physics principles are involved, like there is mechanics, there is thermodynamics, there is some chemistry, all those things are there. But I would like to introduce this particular toy, the drinking bird toy, as a wonderful exhibition of wonderful, just demonstration of the use of thermodynamics, okay, or the principle of thermodynamics. Okay, you may wonder, once you see this toy somewhere, you try to understand that it is working based on some basic laws of thermodynamics. Thermodynamics, always you know that, there is some heat involved, some temperature, some pressure, some volume, all these things. Whenever it is involved in a process, we will call that it is thermodynamics basically. Okay, and what is special about this toy? You can see that this toy has got a special design. Okay, it will have a long beak. Okay, so this is a long beak, and it has got a very long neck. You can see it's a glassy construction, very long neck, and it has got a belly, okay, or a stomach. I can say this is a belly, okay, and it will be, this particular toy will be pivoted on a particular shaft, so that this toy can just make some sort of a dancing motion, rotatory motion. It can come down, see, about this particular axis. So this is an axis. So about this axis, it can rotate. Okay, so what will happen? It will just be raised. So what will happen? The belly will be raising, so that it will be dipping. And if you keep a glass of water here, you can see that a glass of water has been kept in front of this particular, bird. And what you will see is this one. If you just pour some water, if you are pouring some water, some few drops of water on the head of the this bird, what will happen? You will see that this bird will be just kneeling down, or it will be just dipping down, and so that its beak will be dipping into this glass of water. And after some time, what will happen? You will see that the bird will be just raising its head, so that its belly will go down. So the belly will go down, and it will be raising its head like this. Again, you need not do anything. You just observe. You will see that again after a while, the bird will dip its beak into the water, and again to be going back. So we feel that the bird is drinking water from the glass. Okay, and the process will go on continuously. Okay, once you start by dropping some water on the head of the thing, the process is a very very interesting toy that one should observe, and I think as a physics student can always just Google out for such toys. It will be a very wonderful thing. Depending on the design, without any intermediate touching or any disturbance, you will see that this toy can go on working for continuous hours. Okay, so it can go on working continuously without any disturbance for hours. Okay, certainly you will feel, for those who just look at this one as a fancy point of view, you will see that the toy may be working without any battery, without any external energy source. So you will feel that this is just something like the violation of the second law of thermodynamics. Okay, or it is acting something like what is known as a perfect engine, or a perpetual motion machine. I can say better that one, a perpetual motion machine. Okay, and historically, see, this particular toy was designed by an engineer. You can just read it in the Wikipedia. Just you Google the drinking bird. Okay, and this toy attracted the attention of many of the physicists at that time. And it is heard that, it's read that even Albert Einstein was very much fascinated by the working of this particular toy, and he spent hours and hours thinking about, I don't know whether it is exactly hours, maybe it's days, thinking about the working of this particular thing. And it's quite interesting. And the wonder that is associated with the working of this toy, I will just give some hints here. You can just those who are interested to know about this one, those who are curious about knowing the physics behind the working of the drinking toy, you may just Google it out. It's all about the liquid that you are filling in the belly. So there are several liquids which are proposed. One liquid is methyl chloride. So methyl chloride, there is a special chemical, isopropyl or something like that, methyl chloride. That is one of the common liquid that is being used in such toys, methyl chloride, and to give some fancy nature, it is mixed with some red dye. So some color is given to make it more attractive. So several varieties of this thing is on, and you will see that this methyl chloride is a chemical which is having very low boiling point. It boils at its boiling temperature is very close to some 100 degree Fahrenheit. It's given in Fahrenheit. So 100 degree Fahrenheit, that is the boiling temperature. So it boils at a very low temperature. So it will be very easily getting vaporized, and you will see that in the design, actually there will be a glass tube running through the neck. So there will be a glass tube like this. So very narrow glass tube will be there through the neck. You can just see the design. Some very clear pictures are there in the net. So what will happen is that when you pour the water over this one, the vapor inside, there will be a lot of methyl chloride vapor here inside the head region. This is a glassy bulb actually. So what will happen, this vapor will be getting cooled down. The vapor will be getting cooled down due to because this water will be getting evaporated, and you have learned that evaporation will always result in cooling. So evaporation will be resulting in cooling. That is the one reason why you feel cold when you switch on the fan. It's not because you are getting some cold wind to your body. It's because the fan increases the rate of evaporation at your body, and evaporation will always give you a sense of cooling. And due to that cooling down, the pressure inside the head will be getting reduced, whereas the pressure, vapor pressure at the top of the liquid here in the belly region will be high. So what will happen, that the liquid will be forced through this capillary tube, through this particular tube, the liquid will be made to flow into the head, and the weight of the head region will be increasing, and that makes the head to dip down. And once the head dips down, you will see that the bottom end of the tube will become open, and so what will happen, that the pressure difference is now normalized, and you will see, just liquid will be just getting or flowing back to the what do you say back to the belly region, and it will take some time to explain it better, to save time, and for those who are curious about the working of this one, I have just posted or added two short videos from the YouTube as a link. You can just watch it once this session is over, and it will be interesting to know such working Android. It's very good that, or it will be always good that you search after the working of toys, because that is the best way to learn physics also, and to understand that physics is not far away from the reality. Okay, so this is one thing that I propose. So I think we have introduced the Carnot engine, and the working of this particular drinking bird toy can be something very close to what is known as the working of a Carnot engine, or like a perpetual motion machine. We feel that it has got maximum efficiency with a little input, or with a very little input of work, we can produce maximum output. That is an interesting feature to understand. So in the next session, after you watch all these videos, maybe by tomorrow, we will be discussing the cycle of operation undergone by a Carnot engine, which is known as the Carnot cycle, and finally we will derive an expression for the efficiency of a Carnot engine. Okay, thank you.